One operation that you probably don't know how to do is to divide polynomials. Multiplying polynomials is the same thing as distribution. We add polynomials by combining like terms. Subtraction is the same thing. But polynomials and division is something that is probably new. And with that being said, there are two different ways that you can actually divide polynomials. The first way is long division, and I stick with long division first because it's how you know how to divide numbers currently. And then once I show you the synthetic division, most likely you will like synthetic division. It gets rid of the letters. But just to start off with, we'll start pretty simple to start off with, just to make sure that we're okay. So we've got 3x on our outside, and then we've got 12x squared y plus 3x. Sorry, that doesn't really look like 2, huh? All right, so we're taking 12x squared y plus 3x divided by 3x. In case you're curious, I'll just rewrite this. So what this means it's similar to factoring in that I'm trying to figure out how many 3x's are in each term. And it might not always work out. You might have a remainder, and that's okay. So when I'm doing long division, I am trying to figure out how many of these 3x's are within this first term. So in order to get I first deal with the 12. 3 times what number gives me 12? That would be 4. Or you can think of it 12 divided by 3 gives me 4. Now, the variables get a little tricky. So if I have x squared, then I know that I have an 1x. Technically, it'd be x to the first. I have an x on the outside as well. So to get x squared, I have to have x to the first times x to the first, because those two give me x squared. I don't currently have a y, so in order to get the y, I'd have to put the y there. So right now I've got 12x squared y, subtract, I get 0, drop down the 3x. So now my goal is to get the 3x. Well, 3x times 1 gives me 3x. And I do not have a remainder. So like I said, this one was kind of like factoring out the 3x. It gets trickier when you add other terms. When we do this long division, I'm only going to show you a binomial for our actual long division. If we get larger, you won't ever have a situation, at least at this point, where you'll have a trinomial. So if I were to have x minus 6 and then 1x squared minus 1x minus 30. Okay, so this is where a lot of people struggle. They can get the first part, but then they kind of forget about the second part. So you have to remember that this x minus 6 is together as one whole thing. So it's like distribution. So I first look at the first term, the 1x squared. Well, what times x is going to give me 1x squared? Well, 1x. So I've got 1x squared, but I have to distribute that 1x to the 6 as well. So I distributed to the x first to give me that 1x squared, but now I got to distribute to that negative 6 to give us negative 6x. And we subtract. So when I do my subtraction, 1 minus 1 gives me 0. Negative 1x minus a negative 6x actually gives me a positive 5x. Then I need to drop down that minus 30. So now I'm looking for this 5x. So now I'm going to kind of erase the green here. I needed that subtraction, whoops. All right, so I'm looking at that 5x, and I'm supposed to get that. So 5x divided by x gives me positive 5. Now this 5 has been distributed to the x, so I have 5x. Now I also need to distribute that to the negative 6, so minus 30. I then actually subtract these. Everything comes out to be 0. So my final answer then is 1x plus 5. But what about if I don't have it come out to a nice number, aka 0? Then you're going to have a remainder. So we're going to go with a little bit larger scale here on our long division. We have x minus 2 on the outside. We'll have 3x to the 4th minus 1x cubed. Okay, there isn't an x squared, so we have to put that in as a 0x squared. Okay, that's something to note, that when you're doing division of polynomials, you need to have this in standard form in which each term is represented. Okay, that's tricky. A lot of people forget that. All right, so we're going to have quite a bit of long division here, and that was the goal. So I need to figure out how to get that 3x to the 4th. Well, I've got a 1 on the outside of that x minus 2. So I know I'm going to have 3x. Well, I've got 1x on the outside, so I've got to have 3 there. I'm going to distribute to both terms. So I have 3x to the 4th minus 2, not 2, sorry, minus 6x cubed. I'm going to go ahead and subtract those. So negative 1 minus negative 6, which gives me a positive 5x cubed. I need to drop down the 0x squared. Because this is we're dividing by a binomial, I only do 2 numbers at the same time. So for instance, I only drop down the 0x squared. I didn't drop down the rest of it just because I'm already dividing by a binomial, so I know that that other stuff is just going to be left over anyway. So now I'm trying to get that 5x cubed. So I know it's going to be a plus 5x squared. I need to distribute that to both terms. So I have 5x cubed minus 10x squared, which now leaves me with a positive 10x squared, and I drop down that 2x. Okay, I'm going to erase my distribution marks here. So now I need 10x squared, so I'm going to have plus 10x. I'm going to go ahead and distribute. It won't always be a 1 out here as a 1x minus 2. It might have a number in front of it, just an FYI. So I've got 10x squared minus 20x. I'm going to subtract. I get 0 on the first part. 2 minus negative 20 gives me 22x, not 20. I'm going to drop down the 6. I'm going to erase those distribution marks. And now I need a 22x, so I'm going to have plus 22. I'm going to go ahead and distribute those. So I've got 22x minus 44. I'm going to subtract those two. When I do this, though, as you can see, it's not the same. So I'm going to have a remainder, and that's okay. So looking at this, I'm going to have 38 as my remainder. So what we do then in this case, so we know that this top part is that 3x cubed plus 5x squared plus 10x plus 22. So then I'm just going to put, like you did in grade school, remainder 38. If you wanted to get actually real technical and have it in the proper notation, you would have remainder 38 can also be written as 38 divided by x minus 2. We get the x minus 2 because that's what we were actually dividing. So the long division of polynomials, it follows the same rule as normal long division without any variables. It's just one of those things where you got to remember that you got to distribute to the x and the -2 or whatever it is on the outside over here.